Hi everyone, thanks for watching. In this video we're going to take a look at how long it takes different unstable nuclei to decay using the idea of half-life. So remember from the past few videos that unstable nuclei decay, which means they break apart into different smaller pieces. Like if we had this atom of potassium-42 which is unstable, so it breaks apart and decays, gives off a beta particle and turns into a different element altogether. In this case it would be calcium-42. The question for this video is not so much what's happening, but how long it takes this process to happen. So to understand this concept, let's imagine we had a big giant block of potassium-42. In this case, let's say we have 80 grams of it. And we're going to keep track of some information pertaining to this block, this mass, over time, starting with what we'll call the initial time, 0 minutes. How much potassium-42 is left? Technically all of it, 80 grams. Nothing's happened at time 0, at 0 minutes, which means no of the potassium-42 has decayed. Same information in terms of percentages, 100% is left and 0% has decayed so far. Now let's introduce the idea that this potassium-42 has a certain half-life, and in this case that number is 25 minutes, so it's a quantity of time. And don't worry if you think you don't know what half-life is yet, this is the part where you start to actually figure it out. The way it works is if you waited exactly 25 minutes later from our 0 minutes, our initial time, you would have exactly half of the potassium-42 that you started with. So if I started with 80 grams, I've only got 40 grams left. And we can label that on the block to show that there's 40 grams potassium-42 left behind. That means that of the 80, 40 grams of the potassium-42 is gone. It's decayed. You might wonder, what has it turned into? Well, it shows right here in the transmutation that it turns into calcium-42. So now my block is only made of 40 grams of potassium-42. The other half, the other 40 grams, is now calcium. In terms of percentages, 50% of the potassium is left, which means 50% has decayed. And we could do this again. You could wait another 25 minutes. So total 50 minutes have passed. And after that next 25-minute chunk of time, your mass splits in half again. So the 40 grams we had is now only 20 grams of potassium. That means in my 80 gram block, 60 grams of the potassium-42 is now gone and decayed, probably turned into calcium. In terms of percentages, if only 20 grams is left, that's only 25% of my original 80 gram block, meaning 75% has decayed. And by now you should pretty much be getting the idea, but we'll do a couple more runs just in case. If you waited another 25 minutes, so now 75 total minutes have passed, the 20 grams you had before would split in half and you'd only have 10 grams left, meaning 70 grams has decayed. In terms of percentages, there's only 12.5% of the original amount remaining, so 87.5% has decayed. And one more time, 25 more minutes, 100 total minutes now. The 10 grams you had splits in half again to 5. So that means 75 grams has decayed and turned into calcium. In terms of percentages, only 6.25% remains of the original 80, so 93.75% of my original 80 grams of potassium-42 has decayed and turned into calcium. And at this point, you're in a pretty good place to actually define and understand what half-life is. First of all, it's an amount of time. It's about pretty much these two columns right here, these two rows. The time required, so in this case it was 25 minutes, the time required for 1/2 of the nuclei in a sample to decay. That's why every 25 minutes, 80 grams turned into 40, in half to 20, into 10, into 5, and 2.5, and 1.25, and so on if we kept going. That's our official definition for half-life. Before we wrap up this video completely, it's also really important to know that different elements and isotopes have really different half-lives. Some decay very slowly, so they have really long half-lives, like billions or thousands of years, whereas other atoms decay almost instantly. Lithium-8 is gone in an extremely small fraction of a second, so fast you barely even had time to know it ever existed in the first place. And that concludes this video. Thanks for watching.